Hello friends, welcome to sitza.com. Now in this lecture we will learn about the nomenclature of the organic compounds. There are basically two systems of nomenclature. One is called as a common name, and this is the earliest system of nomenclature, and the second one is an IUPAC nomenclature system, which is a modern, and this is what we follow today. In the early stages of the organic chemistry, most of the compounds that were obtained, they were obtained from the natural sources. So most of the compounds, most of the organic compounds that the people got, they were actually derived from the natural resources. So that's why most of the compounds, they were named after the source of the origin, right? So from the source of the origin, accordingly it was the compound got the name. Suppose we got the urea here. The urea, it's named because it was obtained from the urine of the mammals, right? So urea was obtained from the urine of mammals, hence it's got the name urea. Similarly, the methyl alcohol that we know, methyl alcohol here, it was called as the wood spirit. Okay, it was called as the wood spirit here. Okay, and because it was obtained from the direct distillation of the wood, right? So the source of this was wood, hence it was called as the wood spirit. But later on, when compounds were synthesized in the lab and it was not possible to continue with this nomenclature system with the common name, and a lot of compounds were synthesized in the labs, and it wasn't possible to continue with the common name system. A new system of nomenclature was introduced, so which is called as an IUPAC nomenclature system, and IUPAC refers to International Union of Pure and Applied Chemistry. So here in this system of nomenclature, we have well-defined set of rules, and we follow those rules to name a particular compound. Any organic compound has three main parts. It consists of three main parts. One is called as a word root, the second one is suffix, and the third part is prefix. Word root, actually it refers to the number of carbon atoms, right? Okay, it refers to the number of carbon atoms in the molecule. Suffix refers to what kind of a linkage is there between the carbon atoms, right? And prefix refers to whether the molecule is cyclic or is it acyclic. So we'll discuss all these things by taking certain examples. Now word root, as I said, it refers to the number of carbon atoms, right? So word root mentions the number of carbon atoms in the molecule. If it has a one carbon, if the organic compound contains one carbon atom only, so we use the term meth. So the word root is meth for the one carbon molecule, right? Similarly, for the two carbon molecule, it is eth. The word root becomes eth. For three carbons, it will be prop, then but, pent, hex, hept, oct, non, and the dec. So these are the different word roots, and we use it depending on the number of carbon atoms in the organic compound. So similarly, we have a suffix term. So suffix, there are basically two types of suffixes. One is called as a primary suffix, right? And the second one is secondary suffix, right? Primary suffix actually refers to what kind of a linkage is there between the carbon atoms. Is it a single bond, or is it a double bond, or is it a triple bond, right? If there's a single bond between the carbon atoms, so we use the term ane. So therefore the primary suffix will be ane, and if there's a carbon-carbon double bond, so we use the term ene, and if there's a triple bond, so we use the term yne. So this is the primary suffix, right? Primary suffix refers to linkage between the carbon atoms. And secondary suffix actually refers to the functional group. If a molecule contains any functional group, so it refers to the functional group. We will discuss about it later on by taking certain examples. Suffix actually it describes whether the molecule is it a cyclic or is it acyclic, right? So here it differentiates between a cyclic molecule from the acyclic molecule. Prefix is also of two types, the primary prefix and the secondary prefix. So here the primary prefix actually differentiates a cyclic molecule from the acyclic molecule. Secondary suffix here, so sometimes we use a secondary suffix also. So secondary suffix refers to any substituent group if the molecule has, right? If a molecule contains any substitution group, so we use the term secondary prefix for that, right? Let's explain it with a one example. Suppose if I got a molecule like this, a CH3, CH2, single bond CH2, and here the CH3. For this molecule, we find there are 4 carbon atoms, so we will use the term but. The word root will be the but here, right? And then single bond only, so the term will be ane, right? So the name for this molecule is butane. Now let's take another example. CH2, single bond CH2, single bond CH2, single bond CH2, and again a single bond here. Here again we find only 4 carbon atoms, so the word root will be but, right? And there is only single bond, so ane. Ane here is the suffix, right? This is the primary suffix, and but here is the word root. But this molecule is cyclic, right? Isn't it? It's not like this molecule, which is an acyclic. So therefore, for the cyclic, compounds, we use the term cyclo before the name, right? Before the word root, we use the term cyclo, right? So the cyclo here is the prefix for the molecule. So basically, prefix differentiates whether the molecule is cyclic or is it acyclic molecule. Let's take some other examples. Suppose I got here a molecule like this, CH2, CH2, and the single bond CH2. Here we find this molecule is cyclic, so the prefix for this molecule will be cyclo here, and it contains 5 carbon atoms, so we will use the term pent. For the 5 carbon atoms, we use the term pent, cyclopent, and there is only single bond, so it will be pentane, right? Cyclopentane. If you got a molecule like this, CH2, single bond CH2, CH, double bond CH, and the single bond here. Now see, this molecule is cyclic, so the prefix will be here the cyclo, and it contains 4 carbon atoms, so I'll use the term but. And there's a single, double bond over here, so the suffix here will be ene. So the molecule here is cyclobutene, right? This is cyclobutene. Let's take some other examples. See, you have a molecule here. This is in the bond line representation. Okay, basically this one is a carbon, this is another carbon. All these points, they refer to the carbon atoms. Okay, so actually the molecule here, this is the bond line representation of a compound. Let me draw the same structure, like this in terms of carbon atoms. We got 1, 2, 3, 4, 5, 6, 7, 8 here, right? CH2, CH2, CH, and the 4th carbon here has a methyl group attached to it, and there are 4 more carbon atoms, right? This molecule is the same, similar to this one. The only difference here is that this is called as a bond line representation. Okay, here each this point here refers to the 1 carbon atom, right? When you name this molecule, how we name it? See, we have a substitution here, right? This is a substituent group. So how we name it? There are certain well-defined rules. You have to remember certain rules when you name this molecule. So what are the rules? What are those IUPAC rules that you need to remember? First thing is that in a branching chain molecule, we have to first select the longest chain. Okay, that's the first step. We have to select the longest chain, a chain which contains maximum number of carbon atoms. Suppose if I start from here, 1, 2, 3, 4, 5, right? It contains 5. If I start from here, 1, 2, 3, 4, 5, 6, right? But if I start from here up to this point, now 1, 2, 3, 4, 5, 6, 7, 8, isn't it? So that means this is the longest chain here, correct? this is the longest chain. So after you select the longest chain, you have to start the numbering, right? So we have to start the numbering. The numbering should be done so that the substituent group gets the least number. That means if I start the numbering from the left side over here, it will be number 1, this is 2, 3, 4, 5, 6, 7 and 8, right? But if I start from the numbering from the right side, it will be number 1, 2, 3, 4, 5, 6, 7 and 8. The left side numbering gives this particular carbon the value of 4, right? That means the substituent group gets the position 4, right? But if I start the numbering from the right side here, this carbon which is attached with the substituent group gets the number 5. The numbering is correct where the carbon gets the least number, right? So that means right side numbering is wrong, left side here is correct. Okay? Fine. After that, when you name it, we always write down the first of all the substituent group because this becomes the prefix. Okay? Substituent group is a prefix. So here we have a methyl group which is a substituent group. So it will be called as a methyl. But what is the position of the methyl here, right? This is our substituent group, correct? What is the position of, where is it present? It is attached with the carbon number 4 in the longest chain, right? In the main chain, it is attached with the carbon number 4. So I'll mention the position of the methyl group also. So it will be the 4-methyl, 4-methyl, right? So it's called 4-methyl, and there are how many carbon atoms in the longest chain? 8. So the term will be oct. The word root will be oct, and there's only a single bond you can find here in the whole length, right? Only single bond, so it is ANE. The name is 4-methyl octane. Now let's take some other examples. This is the molecule here, and I'm going to select the longest chain. So this is the longest chain here, right? And I'll start the numbering from left side or right side? From the right side, correct. This is the correct numbering. 1, 2, 3, 4, 5, 6, 7 and 8, right? Why don't I start from the numbering from here? Because in that case the substituent group will be 1, 2, 3, 4, right? So this will be the 4 and this will be 6, right? So the set of a locant from the left side, if I start the numbering from the left side, this will be 1, 2, 3, 4, 5, 6, 7 and 8, right? So the set of a locant means the position of the substituent groups that we have from the left side numbering will be 4, 6, right? But the set of a locant from the right side numbering is 3 and 5, right? So here is 3 and 5. The lowest set of a locant is here. This is not, so this one is wrong. Okay, so that means the right side numbering is correct. Okay, when we name this molecule, we have 2 methyl groups here, isn't it? We have a methyl here. So we will use the term dimethyl. But what is the position of the 2 methyl groups? It is 3 and 5, right? 3 and 5. We have a methyl at the 3 and methyl at the 5. So I'll use the 3, 5 dimethyl, right? 3, 5 dimethyl, and in this longest chain here you find 8 carbon atoms, so it is oct, and there are only single bonds, ANE. So 3,5 dimethyl octane. Let's take another example here. We got the longest chain here, right? This is the longest chain. Okay, this is our longest chain, and this is the main chain, and I'll start the numbering from the right side here, right? Because that way I'll get the lowest set of a locant. The substituent group is closer there. 1, 2, 3, 4, 5, 6, 7, 8 and 9. And we got the 2 different substituent groups. One is methyl here. The other one is, this one is actually ethyl, right? Isn't it? This is the carbon CH2 and this is CH3. So the group here is ethyl. Methyl and ethyl. When we name, now see how should we name it? Should I write first the methyl or the ethyl? Okay, here you have to remember that we write down the groups in the alphabetical order, right? So we write down the groups here in the alphabetical order. The one which comes first in the alphabetical order should be written first. So therefore E comes first then M, right? Isn't it? E comes first then M. So therefore we'll write down here the 4-ethyl here, right? Okay, 4-ethyl, 2-methyl, right? 4-ethyl, 2-methyl, non, because there are 9 carbon atoms and only single bond there, so it will be A and E. 4-ethyl, 2-methyl is the prefix here, non here is the word root, okay, and A and E here is the suffix. Got it? Let's take another example. Now see, this molecule is a little bit fancy molecule, right? You can see here this is the longest chain, 1 2 3 4 5 6 7 8 9, and I'll start numbering from this side, 1 2 3 4 5. If I start from here, 1 2 3 4 5, so that means if you either start from this side or right side, is correct in both ways, because you get the position number 5 in either case. Either you start from the left side or the right side, you will get it 5 there, right? So both are correct, whether you start from left side or right side. But this group is a complex, right? It's not a simple, it's not like the methyl and ethyl. Here we have a group which is further substituted, right? It's a branched group. So for the branched groups, how do we name it? We always assign this particular carbon the carbon number 1, and then this will be the 2 and this will be the 3. The carbon which is attached to the main carbon chain is always given the number 1, and then we will start from this one, we will move on. If I start from here, it is 3 carbon, and if I start from here, it is only 1 carbon. So this is the longest chain, so this will be the... Now how should we name it? Okay, here the substitution group has a methyl attached to the carbon number 1, so I'll write down here in the brackets, it is 1-methyl, right? It is 1-methyl propyl, 3 carbons here, so it is propyl. The group is propyl. So this is the substitution group. 1-methyl propyl is the substitution group, and this 1-methyl propyl is attached to the carbon number 5, so it is 5, 1-methyl propyl, and then 1 2 3 4 5 6 7 8 9. This is nonane, right? This is nonane.